Hello everyone, welcome back to the channel. In this video, I am going to discuss another 10 questions from function chapter from Black Book. So let's see. First question is, the number of solution of the equation y plus greatest integer of y whole greatest integer is equals to 2 cos x is where y is 1 by 3 of greatest integer of sin x plus sin x greatest integer plus sin x whole greatest integer is. So let's see here. On first equation, when we are solving, since we are seeing this is a greatest integer, means this is an integral value. So this integral value we can take out of this greatest integer easily, correct now? Because after all it is already an integral value. So we can write down after taking this greatest integer of y outside. So we can write down greatest integer of y plus this greatest integer of y is coming outside. So that it will be there is equals to 2 cos x, right? 2 cos x. So from there you can see this is nothing but 2 times of greatest integer of y is equals to 2 times of cos x. So that will be greatest integer of y is equals to cos x, right? This is our equation number 1. Clear? So now from here you can see y is equals to this greatest integer of sin x we are taking out of this greatest integer. So that will be greatest integer of sin x plus greatest integer of sin x. This greatest integer sin x coming out of this greatest integer, so that we can be written like this one. Correct? Now again same thing here, these two are integral values. After all, greatest integer, we can take these two quantity out of this greatest integer also. So we can write down overall as y is equals to 1 by 3 times of greatest integer of sin x, isn't it? Like that we can easily write down. Now from here you can see this is 3 times of greatest integer of sin x into 1 by 3. So 3 getting cancelled, we are getting y is equals to greatest integer of sin x, everyone. This is our equation number 2, everybody. This is our equation number 2. So by solving first and second equation, we can see here from equation 1 and 2, we can observe that will be greatest integer of y. Y is already greatest integer of sin x. So greatest integer of sin x will be coming at the place of y, and then whole greatest integer. So greatest integer of sin x we can write down is equals to cos x, right? So that will be sin x greatest integer, it's an integral value. Further greatest integer means integral value already it is there. So further greatest integer doesn't make any difference. So we can write down directly that is nothing but sin x greatest integer is equals to cos x. So now we have to focus for what value of x this equation will be hold. Correct now? This equation will hold for what values of x. So let's see here, everybody. Since left side quantity of the equality is a greatest integer, means it's an integral value. So right side quantity must be also equals to the same integral value. Then only this equality holds. So left side quantity greatest integer of sin x can be equal to either -1, 0 or 1. So right side quantity cos x must be also equals to always -1, 0 or 1 for the same values of x for which left side quantity is also coming equal. Correct now? So here we are going to analyze that when cos x is equals to -1, first of all. Cos x equals to -1, we are going to observe for what values of x cos x is equals to -1 is possible. So cos x equals to -1 when we are observing, so that will be possible at all the odd multiples of pi, at all odd multiples of pi. So x can be equals to 2n plus 1 pi, where n will be integer, everybody. If x is this kind of input, then cos will be always -1. For this kind of input, right side of part of the equality is coming -1, but what about left side? At the multiple of pi, sign will be always 0. So sign is 0, so its greatest integer will be always 0. So for this input, this will be 0 and this will be -1. So both are equal? No, both are not equal. So what? These values of x for the equality is not being held here. So cos x cannot be equals to -1. Then what is the next integral possibility for cos x? So cos x we will now check for 0. Cos x will be equals to 0 for what value of x? So you know that at all the multiples of pi by 2, cos x will be always 0. So we can say x is equals to 2n plus 1 pi by 2. Here n belongs integer, everybody. So for this input, cos is always 0. So right side part is 0. But what about left side part? At the multiple of pi by 2, sign will be either plus 1 or minus 1. So its greatest integer will be always either plus 1 or minus 1. So plus 1 or minus 1 cannot be equals to 0. Correct? Right side part will be coming 0 and left side part will be either minus 1 or plus 1. So both cannot be equal. So for these values of x also equality is not being held here. Then what is the next integral possibility for cos? So cos x can be equals to 1 also, another integer, that is the possibility. So cos x equals to 1 for what value of x? When x will be equals to even multiples of pi, means 2n pi, where n will be what here? Integer. N is integer. So cos is for even multiple of pi always plus 1. What about left side of the quality? So left side of the quantity of the equality is coming sin x for multiple of pi. Always even multiple or odd multiple, sign is always 0. So this will be 0, greatest integer will be 0. So right side part will be 1 but left side part will be 0. So both are equal? No, both are not equal. So equality will not hold. So means right side quantity cannot be equals to left side of quantity for any values of x. So here conclusion is no solution, everybody, no solution for this equation. So here which option is correct here? From there you can observe zero solution. Number of solution they are asking, zero solution. A option is absolutely correct. Next question, if we are seeing the function f(x) equals to 0 has 8 distinct real solution and f satisfies the given equation, the sum of all the 8 solution of f(x) equals to 0 is. So it's a very simple question. Since f(x) is satisfying this condition, so this functional equation is being satisfied, means f of 4 plus x is equals to f of 4 minus x, means f(x) graph is symmetric about line x is equals to 4, everybody. Correct? Na? This functional equation is meaning giving that the f(x) graph will be symmetric about the line x is equals to 4. So from there we can say that whatever number of time the graph f(x) will be intersecting x-axis on the right side of x is equals to 4 line, that number of times symmetrically the graph will be intersecting x-axis on the left side of x equals to 4 line. So number of point of intersection of the graph with the x-axis is basically number of root. So 8 distinct real solution means what? 4 on the right side, so it's symmetrically it's 4 will be coming on the left side of the x equals to 4 line, right? Because graph will be symmetric. Not possible that on the right side of x equals to 4 line 5 roots and on the left side 3 roots. Not possible. Why? Symmetry is there. Na? Symmetry about the line x equals to 4 it is. So what we have to do? Roots can be easily we can write down. If suppose let roots will be in that manner. 4 minus alpha is 1 root. So another root symmetrically we can write down 4 plus alpha. If one root is 4 minus beta, so another root will be 4 plus beta symmetrically. One root is 4 minus gamma, so another root is 4 plus gamma symmetrically. Correct? Another root is 4 minus delta, so symmetrically next root can be 4 plus delta. Correct? Correct? So from here you can observe they are asking the sum of all the 8 solution of f(x)s. So sum of solutions means sum of roots. Sum of roots when we are talking. So clearly it is visible when we will be adding all this. So minus alpha plus alpha get cancelled, minus beta plus beta cancel, minus gamma plus gamma cancel, minus delta plus delta cancel. 4 is 8 times, so 8 into 4, which is 32. Sum of root is 32, right? 32. So which option is correct? B option is correct. Next question is, let fx be a polynomial of degree 5 with leading coefficient unity such that f of 1 is equal to 5, f of 2 is equal to 4, f of 3 is equal to 3, f of 4 is equal to 2, f of 5 is equal to 1. Then f of 6 is equal to. So here, this kind of questions, we have to apply little bit logic here. Since given function is fifth degree polynomial and satisfying this given condition, so we will write down the given function by making some arrangement such that a fifth degree equation will have roots 1, 2, 3, 4 and 5. So how can we write down fifth degree equation having these first 5 natural numbers as roots? Obviously, as a product of linear factor, we can easily form the equation fifth degree. One root is 1, so x minus 1 is one of the factor of that fifth degree. One root is 2, so another factor is x minus 2. Similarly, x minus 3. Similarly, x minus 4. Similarly, x minus 5, everybody, right? Now, this is a fifth degree equation which have root 1, 2, 3, 4, 5. Now, this must be transformed from fx. So what transformation on fx we are doing so that this equation will be formed here? That transformation must satisfy this given condition. So how? Let's see here. By using a small logic, we can write down on the left side of the equality as f of x plus x minus 6. This part is logical here. This kind of question you will find out in so many books. So that will be f of x plus x minus 6. So this relation, just a small calculation you will be doing mentally. So you will be getting here. If x is 1, so f of 1 is 5 here. So 5, x is 1, 5 plus 1, 6, 6 minus 6, 0. So this is a fifth degree equation. So equation I am saying, so left side quantity must be equal to 0. If right now, if x is equal to 1 is the root of this, what I am saying, fifth degree equation we had formed, which have root 1, 2, 3, 4, 5, means x is equal to 1 when we are putting this part is becoming what? Yes, 0. This part is 0, means this is equals to this if we are writing, so left side part must be equals to 0. So this given data we will use little bit logic, so we can easily write down f of x plus x minus 6 will satisfy all this given condition. If you are putting 1, so f of 1 is what? Yeah, 5, 5 plus x is 1, 6 minus 6, 0. This is 0. And this is also x is equal to 1, you are putting this is 0, overall 0 satisfied here. Similarly, x is equal to 2 is the root of this fifth degree polynomial, correct enough? Factor of this. So x is equal to 2, you are putting this is overall 0. So this part must be equal to 0. So you can see x is 2. So f of 2 plus 2 minus 4. So f of 2 is 4. 4 plus 2, 6 minus 6 also 0. So 0 is equal to 0 satisfied here. Similarly, 3 you are putting. So this part will be 0. So f of 3 plus 3 minus 6. So f of 3 is 3. So 3 plus 3 is 6 minus 6 also 0. So by using a small logic, we can easily write down a fifth degree polynomial fx by making some arrangement, some additions of some variable or constant. We can easily write down a fifth degree equation which have root 1, 2, 3, 4, 5. Correct now? Or as a product of 5 linear factors. Clear? So what will happen here? They are asking f of 6 is equals to what here? So just put here, question is over, f of 6 plus x is 6, so 6 minus 6, and here if you are writing 6 minus 1, so that is here 5, 6 minus 2, 4, 6 minus 3, 3, 6 minus 4, 2, 6 minus 5, 1. So from there we are getting this 6, opposite sign getting cancelled here, f of 6 is equals to 5 into 4 into 3 into 2 into 1 is 5 factorial. That is nothing but 120. So our answer is 120. In this question only we have to focus on this part, and then whatever they will be asking in the question we can easily answer. Always try to write down whatever degree polynomial will be there, some conditions will be there. We will be trying to write down that polynomial as a product of linear factors which have root 1, 2, 3, 4, like that, whatever information will be given, and that polynomial will be resolved by doing some modification in fx. That modification easily by mental calculation we can write down. Clear? Next question is the number of positive integral values of x satisfying this equation is. So now positive integral value of x they are asking, so we have to only focus in 0 to infinity part first of all. Next, this is a greatest integer, so it will be also integer, it will be also integer. Both integer must be equal for what values of x, we have to just focus on that, right? Now think, for what values of x this will be equals to 0. Correct? For what value of x this will be equals to 0. Why? Because x is belonging in open interval 0 to infinity. This output cannot be negative. These two outputs both cannot be negative for this kind of input. Correct? So in this one, positive outputs always will be integers only, because greatest integer it is given here. So positive outputs or neutral output means 0 is also possible. When this will be equals to 0, we have to focus on that. So x by 9 greatest integer equals to 0 when x will belongs to 0 to 9 in open interval. Since numerator x is less than 9 greater than 0, denominator is exactly 9. So numerator less than denominator, so it will be fraction, greatest integer will be 0. So left side part is 0. And when this is coming 0, right side part is 0 for what value of x? So we have to observe that one. So we are getting here, whenever x is belonging from open interval 0 to open interval 11, means less than 11 greater than 0, then always numerator is smaller than denominator, result will be fraction, positive fraction, greatest integer will be 0. So both will be coming 0, so equality will hold here. Correct? Now? So what are the common values of x such that both will be 0 simultaneously? So from there we have to take their intersection, everybody. What we have to take? Intersection. Clear na? I am just going to take here intersection of this. So what will be the intersection part? Just I am mentioning here, just observe. 0 to 9. Clear? Similarly, when we are observing here, next integral output is possible 1, 1. When this will be left side part will be 1, you can observe when x will be close interval 9 to open interval 18. Correct? Now at exactly 18, it will be 2. Less than 18, it will be what? Less than 2. Greater than or equals to 9, less than 18, means at exactly 9 it will be 1, and in between 9 to 18 it will be 1 point something. So 1 or 1 point something, greatest integer will be 1. And this will be equals to 1 when x will be exactly 11, close interval 11 to open interval 22. In this one always it will be 1. Correct? So we have to take their intersection. So what will be the intersection, so that both will be 1 for the same values of x? So what will happen here? Just observe here. We can see the intersection is coming close interval 11 to 18. Clear, everybody? Now similarly, next integral value is possible as output 2. When this is 2, when x will belongs to close interval 18 to open interval 27, right? And when this is equals to 2, when x will belongs to close interval 22 to open interval 33. So from there you can observe we have to take further intersection. So that intersection will be coming here, close interval 22 to open interval 27, everybody, right? Similarly, next integral output is possible 3, 3. So this is 3, this is 3. This left side quantity is 3 when x will belongs to close interval 27 to open interval 36, right now? And this right side part is 3 coming when x will belongs to close interval 33 to open interval 44. So from there we are getting as intersection when we are taking a intersection. So it is coming here close interval 33 to open interval 36, everybody, right? Now similarly next integral value is possible here 4. So 4 both can be equals to 4 when, so left side quantity is equals to 4 when x will belongs to close interval 36 to open interval 45, and right side quantity is equals to 4 when it will be close interval 44 to open interval 55, right? So from there you can see both will be equals to 4 when we will take here their intersection here. So their intersection is coming what here, just observe here. So their intersection is close interval 44 to open interval 45, right? And similarly we will see when both can be equals to 5. So you know this will be equals to 5 when x will belongs to close interval 45 to open interval 54, and right side quantity is equals to 5 when it will belongs to close interval 55 to open interval 66, right? In this one, so there is anything common we are getting, null is common, so there is no values of x. Similarly next integral value 6 you are seeing here. So for that this will be 6 when it will belongs to close interval 54 to open interval 63, open interval 63, and also you can see this part will be equals to 6 when this will belongs to, this x will belongs to here close interval 66 to open interval 77. Then also not possible that both will be 6 for the same values of x. There is nothing common here also, correct na? So there is no any other values of x for which left side quantity will be equals to right side quantity. Only possible values are these, only these green intervals values, correct? So now in this one what we have to observe, positive integral values of x. Positive integral values we are observing here. So just observe here how many positive integral values, 1 to 8 all the integers. So 1 to 8 integers, 11 to 17, 18 is open interval, so up to 17 all the integers, so 7, 22 to 27, so 22 to 26 if we are seeing here, so 5 integers here it is there, correct? Similarly 33 to 35, less than 36 integral value 35, so 33 to 35 is 3. Similarly 44 to 44 to open interval 45 means only 44, that is 1 only, correct? So number of integral values, just add them. So how much it is here, you can see here 15, 5, 30, 15, 8, 7, 15, 5, 20 plus 3 plus 1, 24, everybody it is 24. So D option is correct here, clear? Next question is mod of log base e of mod of x is equals to mod of k minus 1 minus 3 has 4 distinct roots, then k satisfies where mod of x is less than e square, where x is not equals to 0. So let's solve it. Since mod of x is less than e square, it is given, that means x must be less than or less than e square greater than minus e square, right? That it will be there. Clear? That is the meaning of this. Now we will see 4 distinct roots, then k values should be what for x values in this interval, correct? So we have to draw the graph of these two functions. Two functions in left side of the equality function graph and then right side function graph we will be drawing here. So easily observe here. this given function, let's suppose y is equals to mod of log base e of mod of x whole mod. It is this one's graph when we are talking about. So its graph will be like this. This is our Cartesian plane, x-axis, y-axis, right? Now, log ex, how to draw the graph? Some of you, if you are not knowing, then just observe how to draw the graph. Y is equals to log ex. First of all, graph will be drawing here. So y is equals to log ex, graph will be coming like this one, beta. Clear? This one. This point is 1, 0. And now this x is having modulus, means y is equals to log base e of mod of x. So what will happen? In that case, argument is having modulus. First part, whoever saw the black book, some questions I had discussed in the function first part, first episode. In that one you can see already discuss about this concept. So argument is having modulus, so it's a mirror image about y-axis. We will take whatever graph on the right side of the y-axis available, its mirror image about y-axis on the left side we will take here. This is 1, 0, this is minus 1, 0 right now. Right now, that it is. Now, whole thing is having modulus. Whole thing is having modulus means everything in mod, means it cannot be negative. So what you have to take, when entire function is having modulus, means whatever graph below x-axis, its mirror image about x-axis we will take here. So this portion mirror image will be coming like this one, right? And similarly this portion mirror image will be coming like this one. So our meaningful graph is, everybody, this one only. Correct? The below x-axis graph we are just going to simply remove. This one I had removed. So this is the graph of y is equals to mod or log base e mod of x. Right, everyone? Now this graph we have to observe in minus e square to e square only. So here is minus e square and here is e square. Right? So what will happen here? Just observe, if you are putting here e square, in this part at the place of x, so y can be equals to what here? Log base e of e square modulus, means e square only, this 2 as using logarithmic property will be coming here. We can write down 2 times log base e of e. So this is nothing but 1 only, right? This is nothing but 1 only. So that will be nothing but 2 only, right? So at point e square it will be 2. It will be 2. So since the symmetry is also there, this is what here? Symmetry also there. You can say this point is e square comma 2. So this is symmetry here. So this point will be also same here. E square comma minus e square comma 2. Why? Again modulus is there. This minus will be vanish in the modulus. It will make, it becomes positive. Correct now? And also we have taken the graph, so you know symmetry we will be taking here. That simply I had taken here. So this is the graph now. Just observe on this. This part, this is what here, same here. That is 2. Y is equals to 2 line. Just I am indicating you. Now left side part of the equality is a constant only. This is nothing but a constant. That is here mod of k minus 1 minus 3. So it's a constant only. Constant means graph will be parallel to, x-axis. So parallel to x-axis any graph means horizontal line. It's a constant. Graph will be what here? A horizontal line parallel to x-axis. Graph will be horizontal line. Correct na? Horizontal line that will be there. Parallel to x-axis must intersect at 4 distinct points this graph. Then only 4 distinct routes we can say. So you can see here at 4 distinct point intersection when we are observing. So means like that is possible. 1, 2, 3, 4. So 4 distinct intersection is possible when this horizontal line HL, this horizontal line is lying in the interval 0. This is x-axis means 0 and this is 2. In between 0 to 2, whenever this line is there, this line means this function. So means we can say k minus 1 modulus minus 3 must be less than 2 greater than 0, everybody. Clear? So when we are solving here, that is 3 less than mod of k minus 1 less than 5 here, right? So when we are solving left side part of the equality, so k minus 1 modulus is greater than or equals to 3. It means k minus 1 must be less than minus 3 or k minus 1 must be greater than 3. So from there we are getting k must be less than minus 2, or this one when we are solving k must be greater than 4. So we are getting here, this is here less than, I am saying here less than minus 2, right? Now so now less than minus 2 means minus infinity to minus 2, or means union, and this is 4 to infinity we are getting here. Clear? And also this is left side part of the inequality we had solved here. Now right side part of the inequality when we are solving here, so k minus 1 modulus less than 5. Modulus less than 5 means less than 5. So when we are simplifying this, k minus 1 less than 5 greater than minus 5. So this minus 1 we are sending opposite sides of the inequality. So we are getting here minus 4 less than k less than 6. So we are getting k belongs to minus 4 to 6 here. Correct? So this value should be greater than 0, less than 2, or we can say mod of k minus 1 should be greater than 3 and less than 5. So greater than 3, this is the solution, and less than 5, this is the solution. We have to take intersection. That intersection will be the possible values of k for which this equation will have 4 roots. So we are taking simply intersection here. Clear? So intersection when we are taking 1, intersection 2 when we are writing here. So just observe what it is coming here. 1 intersection 2 is minus 4 to minus 2 union 4 to 6, right? So these are the possible values of k for which this equation will have 4 distinct solutions. So minus 4 to minus 2, A option is correct here, and 4 to 6, B option is also correct. It is a multiple choice question, correct? So that is answer. Next question is, let fx be a polynomial of degree 6 with leading coefficient 2009. Suppose further that f of 1 is equal to 1, f of 2 is equal to 3, f of 3 is equal to 5, f of 4 is equal to 7, f of 5 is equal to 9, f dash 2 is equal to 2. Then sum of all the digits of f of 6 is. So this question is of same concept that we had done previously in this video only. So what we have to do, 6 degree polynomial satisfying this condition. So 6 degree polynomial, by doing some logical arrangement, we will try to write down as product of 6 linear factors which has factor as x minus 1, x minus 2, x minus 3, x minus 4, x minus 5, right? Now so we can write down x minus 1, x minus 2, x minus 3, x minus 4, x minus 5. So 5 factors we are getting this, and since it is a 6 degree polynomial with leading coefficient 2009, leading coefficient means x 2009 multiple I am writing. One of the factor means we can say one of the linear factor 2009 times of x minus alpha. So overall it will becomes 2009 as leading coefficient. So this is a 6 degree polynomial which is coming on doing some logical arrangement on fx. So what are the logical arrangements? So here logically we can observe here f of x minus of two x plus 1 we can write down this, right? So from here you can see, if you will putting here x equals to 1, so f of 1 is 1 only, and 2 into 1 is minus 2. So plus 1 plus 1, 2 minus 2 is 0. Clear? Similarly, x equals to 2 you are putting here. So minus 2 into 2 minus 4 plus 1 minus 3, and f of 2 is already 3. So 3 minus 3 also 0. If you are putting x equals to 3, so f of 3 is 5, and here 3 2 is 6 plus 1. So minus 5 plus 5 also getting cancelled. That is also satisfying. Similarly, x is 4, so 8 minus 8 plus 1 minus 7, and f of 4 is already 7, so satisfying here. So overall, we can transform the fx by doing a logical arrangement that can be represented as a product of 6 linear factors, which are x minus 1, x minus 2, x minus 3, x minus 4, x minus 5, and 2009 times x minus alpha. So this it is. That is only logic. Already I said in the entire this kind of questions, this kind of question available in so many books. You can observe from there also. You can do practice. So from here, one more data they had given f dash of 2 is equals to 2. Then sum of all the digit of f of 6 is, right? So what we can do, we have to find out derivative. So we are going to do differentiation with respect to x. So f dash of x minus of 2x differentiation to 1 differentiation constant 0. No need of mention. Now here it is in the product here. It is in the product here. But it is very tricky here. You can observe here that they are asking derivative at point 2. So what I am saying, this x minus 2 you just treat as one function, and overall the things means this, all these factors as another function. Correct? So we can say x minus 2 is first function and rest of all factors product simultaneously is second function. So first function differentiation into second function differentiation we are going to do. Understanding the x minus 2 as first function and x minus 1, x minus 2, x minus 3, x minus 4, x minus 5 and 2009 times x minus alpha. This all is our second function. Clear? So what we have to do, first function differentiation with respect to x, which is 1 only. Second function as it is, x minus 1, x minus 3, x minus 4, x minus 5, 2009 times x minus alpha. That we had written here. First function differentiation, second one as it is. Plus, now here observe, first function will be as it is, x minus 2, and now second function means what here? Here it was, this was first and this was second. So first function as it is, second one differentiation when we will be doing here. So second one differentiation, in this one also chain rule will be applied. So derivative of second function, d by dx of f2. Let's suppose this is f2 here, correct? That it will be coming f2x, right? So what will happen here? Smartly try to understand here. No need to do differentiation. What will happen here? F dash of 2 when we are writing, f dash of 2 minus 2 is equals to, means x we are putting here 2, put x equals to 2 we are doing here in this one, right? So what will happen here, just observe, f dash of 2 minus 2 is equals to, when we are putting 2 here, so 2 minus 1, 1, 2 minus 3, minus 1, 2 minus 4, minus 2, 2 minus 5, minus 3, and this is 2009 times x, means x is 2, so it is 4018 minus alpha, correct? Plus of this part, x is 2, so 2 minus 2 everybody 0, into derivative of this f2x, whatever we are getting, we will be putting to whatever quantity it is coming, but it will be multiplied by 0 only now, because at x2, 2 minus 2 will be 0, so overall will become what? Overall will become 0 here, right now. So that's why no need to do differentiation. Smartly we are writing here, right? Smartly just we are writing here. So that is becoming 0, no need to mention here, that it is coming here. Now from here you can observe f dash of 2 is already given here. How much? 2 only. F dash of 2 is 2 only. So we are taking this, we are getting 2 minus 2 is equals to, this is minus of 6 into 4018 minus alpha. So this is 0 here. And then this equation we are dividing by minus 6. So this is 0 dividing by minus 6, 0 only, and this minus 6 will be divided by minus 6, 1 only. So 4018 minus alpha is equals to 0. So alpha is equals to 4018. 4018 we are getting alpha value, everybody. Alpha value is 4018. So now they are asking sum of digit of f of 6 is. So we can write down by putting this alpha in this equation, we can easily write down as f of x is, just we are writing as f of x is equals to this x minus 1, x minus 2, x minus 3, x minus 4, x minus 5. This is here 2009 times x minus alpha plus 2x minus 1 plus 2x minus 1. They are asking the sum of all the digit of f of 6. So we will put here at the place of x 6, put x is equals to 6, right? So what we will get here, f of 6 is equals to 6 minus 1 5, 6 minus 2 4, 6 minus 3 3, 6 minus 4 2, 6 minus 5 1, and this is here 2009 into 6 minus alpha. Alpha is here 4018 plus 2 into 6 minus 1, right? So when we will be calculating this, so f of 6 is equals to, this is nothing but 120, and this is here on simplification this one plus 11 we can write down. So overall we are getting as f of 6 is equals to 964331. So they are asking sum of digit. Sum of digit when we are calculating here, so you can see sum of digit. So sum of digit will be what here? Sum of digit. Sum of digit when we are observing. So this is nothing but 26. So sum of digit is 26. So f of 6 is equals to 26 is the answer, everybody. Next question is, let fx equals to x cube minus 3x plus 1. Find the number of different real solution of the equation f of x is equals to 0 is. So let's see. So f of x is equals to 0 they are asking. So f of x is equals to 0. So let's suppose f of x is equals to something t, we can say alpha, anything we can say here. So f of x is equals to t we are saying here, correct? So that is here f of t, this f of x is t, so this is f of t is equals to 0. So f of t is equals to 0, so f of x is this one, so f of t is equals to what here? T cube minus 3t plus 1 is equals to 0, right? Since this is a cubic equation, so this will have 3 roots, alpha, beta and gamma, right? 3 roots will be there. So now you know that the graph of a cubic will be roughly can be drawn, since at infinity it will be infinity and at minus infinity it will be minus infinity, right? That it is. So now we will analyze here. At some integral value we can analyze at minus 2, minus 1. This is origin 0, this is 1, this is 2. In these points, first of all, we are going to analyze the functional value of this f of t. Correct? Na? This is f of t. So f of minus 2 if we are talking here. F of minus 2 if we are talking. F of minus 2. So minus 2 cube. So minus 8 it is. And minus 2 into minus 3, minus 6 plus 1. So that is coming here basically. This is here plus 6. So this is coming here basically minus 1. So f of 2 is minus 1. Similarly, f of minus 1 also, this integral value we are going to analyze here. So f of minus 1 is coming here 1 minus 1 cube is minus 1. 3 minus 3 into minus 1 is plus 3 plus 1. So we are getting from here 3. So plus 3. So at point minus 2, f of t is minus 1. This is here minus 1, you can say. And at point minus 1, it is here plus 3. So this is here plus 3, you can say. Correct now. So roughly just I am putting these points here. Just simply I am just putting some points here. That this is f of t is a cubic polynomial which will be always continuous and it must passes through these points. So here you can see f of minus 2 was minus 1. So here it is minus 1. That you can see. And at point 0, f of 0, if you are analyzing, f of 0 is coming here plus 1. So f of 0 is plus 1. So here it is plus 1, I am saying here. This is here plus 1. And f of 1 when we are observing, f of 1 we are observing, so 1 cube which is 1 only, minus 3 into 1, so 3 plus 1. So this is here minus 1. So this will be what here? Minus of 1. So that is here minus 1. Clear? And at point 2, what we will get here, just observe, at point 2 it will be 8 minus of 6 plus 1. So that is here 3. So plus of 3 it is coming here. So plus of 3 means you can say here it is plus of 3, right? So now graph of a cubic equation is always continuous. F of t is a cubic polynomial, so it is always continuous, and that graph must passes through these functional value that I had shown on the Cartesian plane here. So let's draw a graph passing through this. Since for cubic equation, you know, at minus infinity, it will be minus infinity already I said. So minus infinity to this functional value at minus 2, which is minus 1, to this functional value, and then at minus 1 it is 3 here, then at 0 it will be 1, and at 1 it will be minus 1. So like that, and at point 2 it will be plus 3. So like that. Clear na? At infinity it will be plus infinity, you can say like that, it will be there. So cubic polynomial will be like this. Roughly I had drawn here the figure, so it is coming here like this. Clear? So clearly it is observable that the cubic polynomial is intersecting, the graph of cubic polynomial is intersecting the x-axis at 3 distinct points. These are the points. So these are the point of intersection of the graph and the Cartesian plane. So these are the roots here. Those roots, let's suppose alpha, beta and gamma is, right now. So here alpha, you can see alpha is belonging from minus 2 to minus 1, right now, and beta is belonging from 0 to 1. In between 0 to 1 the beta is coming here, so 0 to 1, and similarly gamma is belonging from 1 to 2. 1 to 2 you can write, correct. So now they are asking find the number of real solution of the equation f of x is equals to 0. F of x is equals to 0. So what will happen here? Since f of x is what here? F of t we are saying by putting here f of x is equals to t, and f of x is equals to t means what here? F of t is equals to 0, so this is becoming a cubic polynomial in term of t. So t will be this alpha, beta, gamma value. T will be this one, t will be this one, t will be this one. So now from this equation, f of x is equals to t. Since this is the graph of f of x, f of t right now, and f of t by replacing t by x, so graph of f of x will also remain same here, correct na? So f of x is equals to t. We will have how many number of solution we have to observe. So f of t graph is this, so f of x graph will be also same here. So we can say f of x is equals to t. So f of x is equals to t means fx graph is this one right now. And when t is alpha, where alpha is in between -2 to -1. So -2 to -1 alpha, any value means it's a constant only, everybody. It is what here? It is a constant only. So any constant in between -2 to -1. So here it is -1. If we are extending this Cartesian plane here, so you can clearly observe that will be somewhere -2, -3 like that. Clear? So when alpha is in between -2 to -1, any fixed constant. So -2 to -1 means anywhere. Any fixed constant graph will be what here? Horizontal line. Horizontal line means what? In between -2 to -1, like this it will be coming here. So it is intersecting. This constant is intersecting this f of x graph, means t is equals to f of x. T is what here? Alpha. Alpha is what here? Constant. So this constant is intersecting f of x graph. This is now f of x. F of t is f of x only. So what it is? How many number of point it is intersecting? One time only. So one root. How many root? One root in this case we are getting here. One root, correct? And when t is beta, where beta is in between 0 to 1. In 0 to 1, any constant, if we are talking about any constant in 0 to 1. So in 0 to 1, any constant graph will be also a horizontal line. In this case, the horizontal line, let's suppose this is the our another horizontal line in 0 to 1. 0 to 1 here. 0 to 1 means here, in between this 0 to 1, it is coming here. This is here 0, this is here 1. So any horizontal line in between 0 to 1 is intersecting 1, 2 and 3 points. So 3 roots you can say here. 3 roots, right? 3 roots. And similarly, when t is in between 1 to 2, in between 1 to 2 everyone. So f of x is equals to t, where t is 1 to 2, any constant. So constant graph, another horizontal line which will be in between 1 to 2. So 1 to 3 is this. So 1 to 2 in between this only, somewhere it will be coming. So it is intersecting also at 3 point only. Correct now? So we are getting overall f of x is equals to 0 has number of different solution as. In this case also 3 roots we are getting here. So total number of roots is what here? 3 plus 3 plus 1, 7 roots, everybody. 7 roots are possible for f of x is equals to 0. So this is really nice question. So 7 is the answer of the given question. Next question is, if px is a polynomial of degree 4 such that p of -1 is equals to p of 1 is equals to 5 and p of -2 is equals to p of 0 is equals to p of 2 is equals to 2. Then find the maximum values of p of x is. Okay. So here p of 0 is equals to 2. This is given here, means constant term in the 4th degree polynomial will be 2 only, because p of 0 is equals to 2. So let's write down the 4th degree polynomial. Let's suppose px is equals to ax to the power 4 plus bx cube plus cx square plus dx plus e. E is a constant, that constant can be equals to 2 here. Now it is given p of -1 is equals to 5. So x we are putting -1 in px, so that must be equals to 5. So we are writing a 5 is equals to x is -1, so a into -1 to the power 4, that is a only, that is minus b, that is plus c, that is minus d, that is plus 2. And similarly p of 1 is equals to 5. So here again this is 5 is equals to a plus b plus c plus d plus 2. Correct? So on solving these two equations, you can observe here, this is our equation number 1, this is equation number 2. So what I am saying, just going to add them. Just going to add them. 1 plus 2 when we are doing here. So what will happen, just observe. This is 10 here. And this minus b plus d cancel, minus d plus d cancel. This is 2 times a. So 2 times of a plus 2 times of c, 2 common here, plus 2 times of 2 it is here, which is 2 common, so 2 only we can write down. So this is here, this 2 I am just dividing this 10, so that is here 5. So we are overall getting here a plus c is equals to 3. A plus c is equals to 3. This is one of the information we are getting. Similarly, when we are going to subtract here, what we are going to do? Subtraction here. We are going to do subtraction. So what will happen here? Just observe. When we are doing subtraction here. So what will happen here, just observe. In the part of subtraction, minus, 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 minus. So you can see this part is easily getting cancelled, minus d, minus d. So 2 times everything is coming here also. This is here, 5 minus 5 is also 0 here. So that is 2 times of this minus a plus a getting cancelled. And this is here minus of 2 times b. And this is minus c plus c also getting cancelled, minus of 2 times d here, right? So overall we are getting b plus d is equals to 0 here. Another information we are getting here, b plus d is equals to 0, correct? Now one more thing is given, that is p of minus 2 is equals to 2 and p of 2 is equals to 2. So let's use these two datas. So p of minus 2, when we are putting that, equals to 2 here. So p of minus 2 is equals to 2. So we can write down 2 is equals to minus 2 to the power 4 into a, so that is 16a, minus 8b plus 4c minus 2d plus 2, and p of 2 is equals to 2. So here again 16a plus 8b plus 4c plus 2d plus 2. Now let's suppose this is our equation number 3, this is our equation number 4, everybody. So now again we are just going to do here subtract third minus fourth. So we are doing subtraction, 3 minus 4 when we are doing here. So what will happen, just observe here, subtraction when we are doing here. So this is getting cancelled here, and this is also getting cancelled here, and that is here minus of 8. We can write down it as 2 times of minus 8b, and this minus 4c plus 4c getting cancelled. This is minus of 2 times d, and this is minus 2 plus 2 also getting cancelled. So we are getting here basically 8b plus 2d is equals to 0. So which is here 4b plus d is equals to 0, we can say, right? This is one more information we are getting here. Clear? Now similarly we are going to add third and fourth equation. Third and fourth equation when we are adding here, so see what will happen here. Third and fourth when we are adding here, so what will happen, just observe. So when we are adding them, so that is here 4 is equals to, this is here 32a, this is getting cancelled here, this is 8c, this is getting cancelled here, you can see, and that is plus 4, right? So from there we are getting 32a plus 8c is equals to 0. 32a plus 8c is equals to 0. So that is nothing but 4a plus c is equals to 0, right? So we have 4 equations, so we can solve these 4 equations and we can easily get a, b, c, d values. So p of x we can easily find out here. So by solving this and this, we can observe, since b is equals to minus d or d is equals to minus b, we can say. So d is equals to minus b, when we are saying here d is equals to minus b, so that will be 4b minus of b, that equals to 0 means 3b is equals to 0 means b is equals to 0. B is equals to 0 we are getting here. Clear? B is 0, so obviously d will be also 0. B will be 0, so d will be also 0. Clear? So these two data we are getting. And similarly when we are going to solve this one and this one, so here c is equals to minus 4a, so c is equals to minus 4a, so a minus of 4a is equals to 3, so that we will get here a is equals to minus 1, a is equals to minus 1, so a is minus 1, so c will be equals to 4 here, c is equals to 4. So a, b, c, d, all 4 values we are having here, so we can write down here what is here p of x here. So let's write down the p of x. So p of x we are getting, p of x is equals to a, which is minus 1, so minus x to the power 4, b, which is 0 here, no need to mention, C, which is 4. So plus of 4 times x square, 4 times x square, plus of dx, d is 0, so overall 0, plus 2. So our px is coming this one, everybody. Our px is this. We will find out its a first derivative. So first derivative p dash x is equals to minus of 4x cube plus 8x, right? So from this first derivative equals to 0, we will get its critical point. So we are getting minus 4x as common here. So x square minus of 2 is equals to 0. So critical point as 0 comma plus root 2 comma minus root 2. Clear now? Now they are asking maximum. So maximum or minimum will always occur on the critical point. So we can use here directly maths operator, and then we can observe f of 0, f of root 2 and f of minus root 2. Since here you can see the equation variable is having even power, so plus root 2 minus root 2 will be coming same value. So we can find out any one of them, same it will be there. So f of 0 is coming 2 here, and similarly f of root 2 when we are talking here minus of 4, and here that will be plus 8. So minus 4 plus 8 is plus 4 plus 2, 6 here. So f of minus root 2 is also 6 here. So among this maximum is coming here 6. So answer for this question will be 6 here, everybody. Next question is, let fx be a continuous function such that f of 0 is equals to 1 and f of x minus f of x by 7 is equals to x by 7 for all x belongs R. Then f of 42 is equals to. So let's solve it. So given data, f of x minus f of x by 7 is equals to x by 7. We can write down this x by 7 in the cross multiplication in the whole denominator. So we can write down it as f of x minus f of x by 7 upon x by 7 is equals to 1, right? Now this denominator I will try to write down as x minus x by 7. So x minus x by 7 we are writing, so that is becoming here 6x by 7. 6x by 7. So basically 6 we are multiplying here in the denominator of left side quantity. So right side quantity will be also multiplied by 6 here. That it is. So now 6x by 7 is nothing but x minus x by 7. Now x minus x by 7 only. Right? Now we are taking limit x tends to 0 on both sides. So limit x tends to 0. That is here f of x minus f of x by 7 upon x minus x by 7 is equals to 1 by 6. So this left side quantity of the equality is representing what? Derivability of the given function at point x here, right? So we can write down f dash of x is equals to 1 by 6. So f of x will be what here? On integrating on both sides with respect to x, f of x is equals to x upon 6 plus integrating constant c. F of 0 is equals to 1 given here using this data. X is equals to 0, so f of 0 is 1. So that 0 by 6 plus c. So we are getting a c is equals to 1 here. C is equals to 1, so we are getting f of x is equals to x by 6 plus 1. So f of 42 is equals to 42 by 6 plus 1, which is nothing but 8. So 8 is the answer of the given question, everybody. 8 is the answer. Next question is, the range of function fx is equals to greatest value of 1 plus sin x plus greatest value of 2 plus sin x by 2 plus greatest value of 3 plus sin x by 3 plus dot dot greatest value of n plus sin x by n for all x belongs closed interval 0 to pi where n belongs to natural number is. So let's solve it. So since 1, 2, 3, these all are integral values, so all the integral values we can take out of this greatest integer part. So we can write down it as f of x is equals to 1 plus of greatest integer of sin x plus 2 plus greatest integer of sin x by 2 plus 3 plus greatest integer of sin of x by 3 plus dot 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 n plus greatest integer of sin of x upon n, right? So all these natural numbers 1, 2, 3 summation up to n we can write down as n into n plus 1 by 2, right everybody? and all the integral parts, greatest integer parts, we can write down together sine x greatest integer plus sine x by 2 greatest integer plus sine x by 3 greatest integer plus dot dot greatest integer sine x upon n, right? Now here we have to analyze that when x is belonging from 0 to pi, in this interval the range of fx will be what here? Since this is a fixed constant plus this quantity is going to be added here, and this is the greatest integer every individual term. So now we have to observe the sine x value in 0 to pi. If we are analyzing, sine x will always belong close interval 0 to 1 when x will be in close interval 0 to pi. For this interval we are talking, right? So first of all, if sine x will be 1, so for the same x, sine x by 2 cannot be equals to 1, right? Sine x by 3 cannot be equals to 1, like this sine x by n cannot be equals to 1. If sine x equals to 1, sine x equals to 1 means what? X is equals to, we are taking pi by 2, everybody. X is equals to, we are taking pi by 2. So that will be exactly 1. Sine x will be 1, its greatest integer will be 1. But that will be pi by 4. So pi by 4 means sine pi by 4 means it will be 1 by root 2, greatest integer will be 0. This will be pi by 6, greatest integer will be sine of pi by 6, greatest integer 0. This will be also 0. So when x is pi by 2, so this is only 1, rest of all is coming 0 here. Correct? Clear everybody? When we are taking x is equals to pi by 2. Similarly, when we are taking x is equals to pi, in that case, x is equals to pi when we are taking here. So at pi, this part will be here 0 and this part will be here sine of pi by 2, which is 1 here, right? This part will be 1 and this part will be what here? Pi by 3, sine of pi by 3 0, sine of pi by 4 0. Similarly, all the terms will be coming here 0 in this case. Means x is pi by 2, so first term will be 1, rest of all will be 0. When x is pi, the second term will be 1, rest of all terms will be 0. Correct? If x is pi by 2 or pi, so individually at pi by 2, first term is 1 and at pi, second term is 1. Otherwise, every term is becoming 0 here. And if x is neither pi by 2 nor pi, then you can see none of them. X is, I am writing here, when x is not equals to pi by 2 or pi in this interval, so every term will be equals to 0. Every sign will be what here? Every sign term will be giving you 0 or fractional value whose greatest integer will be 0. This will be also 0. This will be also 0. Means when x is not equals to this, then all the terms, all these terms are coming 0 here. Correct? Na? So what are the possibilities? Means overall these things summation can be equal to at most 1 when x will be either pi by 2 or pi. If pi by 2, so first term will be 1, rest of all 0, so summation is 1. If x will be pi, so second term is 1, rest of all 0, so summation is 1 here. So overall this term summation can be 1 in these two inputs. In these two inputs, what are those inputs? Pi by 2 and pi. Correct? Na? So n into n plus 1 by 2 plus of, we can say this can be maximum, its possibility is coming to be 1 here. Correct? This is one of the value. Otherwise, if x is not equals to this, so you know every term is coming 0 0. Correct? Na? So all these will be 0. So 0 will be added in n into n plus 1 by 2. So that will be n into n plus 1 by 2 only. Correct? So we are getting only two possible values of fx is there. One is n into n plus 1 by 2 and another one is n into n plus 1 by 2 plus 1. Correct? Now this is the range of given function. So we can say this RF in more simplified manner as n into n plus 1 by 2, and this one if you are solving a n square plus n plus 2 by 2, right? So which option is correct? D option. D option is correct, everyone.